Hello, and welcome to the Sleepy Starlight channel. I am so glad you're here tonight. Perhaps your day was long, filled with thoughts and endless noise. Or maybe you're simply looking for a calm place where science and wonder meet silence and serenity. Here, every story is told slowly, gently, and with a dreamy touch so you can relax, unwind, and drift into peace. Together, we will explore mysteries both near and far, from the stars above to the secrets of Earth, from the depths of the oceans to the echoes of ancient history. You do not need to do anything, just rest. Let your breathing soften, let your thoughts grow quiet, and allow your mind to open to the gentle rhythm of discovery. Now, let us begin our journey. So, let us dive into the story of Asteroids, the ancient rocky wanderers drifting through the solar system, silent witnesses to its birth. They do not shine like bright stars, they do not blaze with fire like the sun, and they do not turn with grandeur like the planets. They seem insignificant, merely fragments of stone left behind in space. Yet within their silence lies a great history. They are the leftover building blocks from which another planet might have formed, but fate decided otherwise. Between Mars and Jupiter, in the region where a new world could have arisen, their path was interrupted by the mighty pull of a giant. Jupiter, with its immense weight and gravity, disrupted the harmony. Instead of a single large planet, a belt of millions of bodies remained, from tiny stones to giants hundreds of kilometers across. This is the asteroid belt, a cosmic graveyard and a museum of primordial times. If all these fragments were gathered into one body, the result would be a planet smaller than Earth, but still significant. Yet they remain scattered, like a puzzle no one has ever completed. And in this fragmentation lies their special value. Each asteroid preserves ancient material, largely unchanged for billions of years. Stone, metal, ice, these are relics of the solar system's childhood, frozen moments from its formation. Picture the early solar system. Around the young sun swirled clouds of gas and dust. From them, protoplanets emerged, great spheres of matter colliding, breaking, and reforming. Worlds were born in fire and destruction. Asteroids are the ones that never became worlds, but instead kept the memory of those violent days. Some are little more than heaps of rubble held together by weak gravity. If you stood on their surface and jumped, you could float away into space, never to return. Others are made almost entirely of metal, iron and nickel, shining and heavy, like shards of planetary cores. Still others contain water in the form of ice. Perhaps it was such bodies that once delivered water to Earth, filling the oceans from which life emerged. But asteroids do not always remain distant. At times their paths cross with Earth's. Most encounters are harmless. Small stones burn in the atmosphere, flaring as meteors, the falling stars we watch with awe. Yet sometimes the visitors are far larger, capable of changing the course of history. We know that it was an asteroid that ended the age of the dinosaurs. About 66 million years ago, a massive rocky body struck Earth, unleashing an explosion that darkened the skies and transformed the climate. Worlds can perish from such impacts. Life can end. And yet, such catastrophes also open the way for something new. If not for that collision, perhaps great reptiles would still rule the Earth, and humanity would have had no place here. Asteroids remind us that the cosmos is not indifferent. It is beautiful and silent, but hidden within, it is a force that can alter the destiny of planets. Still, this is not malice. only the natural unfolding of events, the eternal play of gravity and time. For scientists, studying asteroids is like reading an ancient book. Each stone speaks of another age. Carbon-rich asteroids carry organic compounds, clues to how life might have begun. Metallic asteroids reveal the secrets of planetary interiors. Rocky ones, the most common, bear surfaces scarred with craters, records of billions of years of wandering. Some asteroids are well known by name. Ceres, the largest in the belt, is so massive that it is classed as a dwarf planet. Pallas and Vesta, giant bodies, once had internal activity like true worlds. And then there are the tiny ones, only a few meters across, almost invisible, yet still dangerous if their paths ever intersect with ours. Sometimes asteroids come very close, known as near-Earth objects. These travelers pass within the distance of the moon, and some even closer than our artificial satellites. Research centers around the world track their orbits with care, calculating trajectories, predicting their future paths. For now, none poses a direct threat in the coming decades, but their existence itself is a reminder. The cosmos is alive, the cosmos is moving, and we are part of its vast and unpredictable pattern. There is another side to asteroids, hope. Scientists see them as immense sources of resources. Within them lie rare metals, water ice that could be turned into air and fuel. Perhaps one day humanity will turn to these rocky islands to build a civilization among the stars. Then asteroids will not be a threat but a foundation, stepping stones into space. But for now, they remain wild and free. Each asteroid moves along its orbit, guided only by gravity. There is beauty in their motion, silence, steadiness, the endless circling around the sun. They remind us that time in the universe is measured not in days and years, but in epochs where the lives and deaths of worlds intertwine in an endless dance. So begins the story of asteroids, wanderers, keepers of antiquity, and possible heralds of the end. We will follow their paths, peer into their shadows, and search within them for both danger and salvation. For they are the key to understanding how our story began, and perhaps how it may one day conclude. Asteroids are not only silent wanderers of space, they are also messengers of change, sometimes gentle, sometimes catastrophic. To understand their place in Earth's story, we must look back into deep time when their paths and ours have collided. For while many asteroids pass by unseen or burn harmlessly in the atmosphere, a few have struck with such force that they reshaped the planet, altering climates, ecosystems, and the very course of evolution. The most famous of these events is the impact that ended the reign of the dinosaurs. About 66 million years ago, a massive asteroid, roughly 10 kilometers across, struck near what is now the Yucatan Peninsula in Mexico. The collision released energy greater than the detonation of billions of nuclear bombs. In a single instant, a crater over 150 kilometers wide was gouged into Earth's crust, and firestorms raged across continents. The sky darkened with dust and ash, sunlight was blocked, and temperatures plummeted. Plants withered, oceans cooled, and the chain of life broke. 3 out of every 4 species vanished, including the great reptiles that had ruled for over 100 million years. And yet, in the shadow of destruction, new life flourished. Mammals, once small and hidden, rose to fill the empty niches. From them would eventually come primates, and from primates, humans. In this way, the asteroid that seemed to end everything also began something new. It was not merely an end, but a turning of the page. But this was not the first time asteroids had transformed Earth. Far earlier, during the heavy bombardment period over 4 billion years ago, the young Earth was constantly struck by space debris. Mountains were shattered, seas boiled, and the surface was remade again and again. Some of those impacts may have delivered the water and organic materials that seeded life. Others nearly sterilized the planet. Earth's history is written in stone, but also in collisions. There are traces of ancient craters all over the globe, though time has softened many of them. In South Africa lies the Vredefort crater, more than 300 kilometers wide, formed over 2 billion years ago. It is so old that erosion has worn down much of its structure, leaving only a faint circle of mountains around its heart. In Canada, the Sudbury Basin stretches over 250 kilometers, scarred into the land by a massive impact nearly 2 billion years ago. These craters remind us that Earth has long been a target in the cosmic game of chance. Even more recent strikes have left their marks. The Tunguska event in Siberia in 1908 flattened thousands of square kilometers of forest. Though the object was small, perhaps only 50 meters wide, it exploded in the atmosphere with the power of a massive bomb. No crater was formed, but the devastation was vast. If such an asteroid had struck a populated region, the loss would have been unimaginable. In 2013, another smaller asteroid entered Earth's skies above Chelyabinsk, Russia. This one was only about 20 meters across, but its airburst shattered windows across the city, injuring over 1,000 people with flying glass. It was a reminder that even modest asteroids can be dangerous, especially in a world filled with human settlements. Asteroids have also played a quieter role in Earth's history, delivering the building blocks of life. Some carry carbon compounds, amino acids, and water ice. When they strike, these ingredients are spread across the surface. Scientists believe that much of Earth's water, and perhaps the seeds of organic chemistry, came not from the planet itself, but from countless impacts long ago. In this way, asteroids were not only agents of destruction, but also bringers of life. And so, when we speak of asteroids and the end of Earth, we must remember both sides of their nature. They can extinguish worlds, but they can also create them. Without asteroids, perhaps Earth would be a barren rock, without oceans, without green forests, without us. With them, life found its chance, but always at the edge of danger. This duality is what makes asteroids so fascinating. They're both threat and gift, both sword and seed. Each one carries within it the power to end an age or to begin a new one. When we gaze up at the night sky and see a meteor streak across it, we are witnessing that ancient balance, beauty and peril, destruction and creation, all in a single glowing line. As we continue deeper into their story, we will see how humanity has learned to watch the skies more carefully. We will explore how modern science tracks asteroids, how we measure their paths, and how we prepare for the possibility of another great collision. For the story of asteroids is not only about the past, it is also about the future, and the question of how we might face the next visitor from the void. Asteroids are not simply random wanderers drifting without order. Each one follows a path carved by the gravity of the sun and nudged by the invisible hands of planets. These orbits can be stable for millions of years, circling calmly in the asteroid belt, or they can be chaotic, slowly shifting until the object crosses Earth's neighborhood. To understand the risks, humanity has turned to careful observation, building a network of eyes on the sky. Modern telescopes scan the heavens night after night, looking for faint points of light that move differently from the stars. Stars stay fixed relative to one another, but an asteroid creeps across the background, its motion betraying its presence. Each detection is logged, compared, and tracked, building a map of orbits. Some asteroids are rediscovered after years of silence, their paths recalculated with greater precision. The most concerning are called near-Earth objects, or NEOs. These are asteroids and comets whose orbits bring them within 1.3 astronomical units of the Sun, close enough to cross Earth's orbit. Among them, some are labeled potentially hazardous objects, meaning that their size and trajectory are such that, in theory, a future collision with Earth could occur. Thousands have already been cataloged, ranging from small rocks only a few dozen meters across to giants over a kilometer wide. Yet despite this effort, our catalog is incomplete. Small asteroids are difficult to detect until they come very near. The Chelyabinsk meteor of 2013, for example, was unseen until it exploded in the atmosphere. Large asteroids, the ones that could cause global catastrophe, are easier to spot, and scientists estimate that we have already found the majority of those. But smaller bodies capable of devastating cities or regions remain largely hidden. The sky is vast, and our watch is still imperfect. Tracking these bodies requires more than spotting them once. Their orbits must be calculated, taking into account not only gravity, but also subtle effects like the Yarkovsky effect, where sunlight heats one side of a rotating asteroid, causing it to emit heat unevenly. This tiny push over years can alter its path. Such details matter when predicting whether an asteroid might one day intersect Earth's orbit. To organize this knowledge, scientists maintain systems that continually update asteroid risk assessments. NASA's Sentry system, for instance, computes possible future impacts for known objects. Most of the time, potential risks vanish as more data refines the orbit, but the exercise is essential. Each calculation is a rehearsal for the day when one prediction does not fade, when an asteroid's path points directly toward Earth. And so the question arises, what can we do? Deflecting an asteroid is no simple task. Their sizes vary, their shapes are irregular, and their surfaces can be loose rubble rather than solid rock. Hitting them with a spacecraft may scatter debris, but whether it changes their path enough is uncertain. Still, humanity has begun experimenting. In 2022, NASA's DART mission deliberately struck the asteroid moonlet Dimorphos. The collision altered its orbit slightly, not by much, but enough to prove the concept. For the first time, humans changed the path of a celestial body. It was a small step, but it showed that the idea of planetary defense is more than science fiction. Other ideas have been proposed. One is to use gravity tractors, spacecraft that fly near an asteroid for years, their tiny gravitational pull slowly nudging the rock onto a safer path. Another is to use lasers or mirrors to heat one side, encouraging gas or dust to vent and push it gently away. Even nuclear devices have been suggested, though such an approach carries its own risks. The goal is not to destroy an asteroid, for breaking it apart might only create multiple dangerous fragments, but to shift it slightly, enough that Earth and asteroid pass harmlessly by. For all these efforts, time is the most precious resource. To deflect a large asteroid, we would need years or even decades of preparation. A warning of only months would not be enough. That is why discovery and tracking are vital now, long before any danger arises. By finding and cataloging these objects, we give ourselves the chance to act when the need comes. Yet, there is also a humbling truth. Not every asteroid will be caught, and not every trajectory will be clear. Space is full of surprises, and the possibility of sudden impacts remains. The task of science is not to remove uncertainty, but to reduce it, to prepare as best we can, while accepting that some mysteries remain beyond control. Still, the progress is remarkable. A century ago, asteroids were distant curiosities. Now they are carefully tracked neighbors, their orbits mapped, their risks measured, their resources considered. Humanity has begun to see them not only as threats, but also as opportunities. Missions like OSIRIS-REx, which collected samples from the asteroid Bennu, return not only material, but also knowledge. These rocks tell stories of the early solar system, of chemistry that may have seeded life, of worlds that never came to be. Asteroids are, in this sense, teachers. They remind us of our vulnerability, but they also expand our vision. They show us how small actions, a spacecraft's nudge, a calculation on a screen, can echo across cosmic scales. They remind us that we are participants in the drama of the solar system, not merely observers. As we move forward, we will consider another side of the story, the cultural and mythological role of asteroids. For though they are often silent, humanity has filled them with meaning, from omens of doom to symbols of discovery. The next part of our journey will take us through those stories where science and imagination intertwine, and where the fall of a stone from the heavens has always meant more than rock and fire. From the earliest days of human history, the night sky has been more than a backdrop. It has been a stage, and every flicker of light upon it became part of a story. Among the most powerful of these lights were meteors, sudden streaks that cut across the heavens, startling in their brilliance. To us, they are fragments of asteroids or comets burning in the atmosphere, but to ancient eyes they were messages, omens, or even gods speaking through fire. In Mesopotamia, the cradle of civilization, the fall of a star was never taken lightly. Priests who watched the skies believed that meteors were warnings from the gods. A sudden streak across the sky might mean the death of a king, a change in power, or a coming disaster. The sky was seen as a book, and the fiery trails were words written by unseen hands. In a world where survival was uncertain, the heavens were studied not only for beauty, but for guidance, and meteors became part of that divine language. The Greeks, too, wove these celestial events into their myths. A falling star might be the passing of a soul or the favor of a god bestowed upon mortals. Aristotle speculated that meteors were flames ignited in the upper air, but for most people, their meaning was far more personal. To see a streak of light was to glimpse the will of the cosmos. Even today, when someone sees a shooting star and makes a wish, they are echoing an ancient belief that the heavens open for a brief moment, allowing human hope to reach beyond Earth. In Rome, meteors were linked to destiny. The historian Pliny wrote of fireballs as signs of divine judgment. Soldiers on campaigns sometimes took a falling star as an omen of victory or defeat. A single streak could turn courage into fear or despair into hope, depending on the story told about it. For the Romans, the sky was not distant. It was close, alive, and filled with meaning. In many cultures, meteors were thought to be spirits. In some Native American traditions, they were believed to be the souls of ancestors traveling across the sky, watching over the living. Among the Maori of New Zealand, a bright meteor could represent a chief spirit leaving the earth. In Polynesia, where navigation was guided by the stars, meteors were seen as powerful signs from the heavens, connecting the sea voyagers to their gods. In China, records of meteor showers stretch back for thousands of years. Ancient astronomers carefully documented the dates and directions of these events, interpreting them as signs of imperial fortune or misfortune. A sudden shower of falling stars might be seen as heaven's displeasure with the emperor, a warning of rebellion or natural disaster. These records, precise and abundant, are some of the earliest systematic observations of meteors, blending myth with proto-science. In medieval Europe, meteors often carried darker meanings. A blazing fireball could be seen as a sign of war, plague, or the wrath of heaven. Chronicles of the Middle Ages often mention stars falling before great battles or calamities. Yet there was wonder, too. Poets described meteors as sparks from the forge of heaven, or as arrows of light loosed across the sky. For ordinary people who lived under darker skies than we do today, meteor showers like the Perseids or Leonids would have been overwhelming spectacles, sudden storms of light breaking into the night, unforgettable and awe-inspiring. Islamic tradition also holds unique stories of meteors. In the Quran, they are described as stones hurled against devils who attempt to steal knowledge from the heavens. Thus, meteors were seen as protectors, defending the purity of divine truth. In this vision, the fiery streaks are not random, but purposeful, part of the order of the universe itself. Across Africa, stories varied but carried a common thread of respect and fear. In some regions, a falling star was thought to announce a birth, in others, a death. Among the Zulu, meteors were believed to be fiery serpents crossing the sky. To see one was to glimpse the hidden world of spirits, a reminder that the boundary between earth and sky was never as solid as it seemed. What is striking is how universal these beliefs were. From one culture to another, meteors and asteroid impacts were rarely seen as ordinary. They were extraordinary by their very nature, events that broke the stillness of the sky. Their rarity gave them weight. Each fireball, each sudden streak was a reminder that the heavens could change without warning, that the cosmos was not only vast, but alive. And there were times when the heavens did more than hint. Large impacts, remembered in myth, became woven into cultural memory. Some stories describe great fires that fell from the sky, burning forests and reshaping landscapes. Others tell of gods casting down stones in anger. While science now explains these as asteroid strikes, the stories themselves capture something true. The sky does sometimes reach down to earth with fire. Even today, in our scientific age, the mythology lingers. We still wish on shooting stars. We still call them falling stars, even though they are not stars at all. Meteor showers continue to draw people out into the night, gazing upward together in silence. The ancient awe remains, threaded through with new knowledge. We know now that they are fragments of comets or asteroids, burning for a brief instant before vanishing. But the wonder is unchanged. Asteroids, meteors, and impacts have thus lived double lives in human history. They are both natural events and symbols. They are studied with telescopes and equations, but also with poetry and prayer. They remind us that the line between science and story has always been thin, that humanity has always needed both explanation and meaning. As we move forward, we will leave behind these myths and return to the science. We will explore the asteroid belt in detail, the families of asteroids it contains, and the strange diversity of these bodies, rubble piles, metallic giants, and icy wanderers. For if myths tell us how humanity has seen the sky, the science of the asteroid belt tells us how the sky truly is. Between the orbits of Mars and Jupiter lies one of the most intriguing regions of the solar system, the asteroid belt. At first glance, one might imagine it as a crowded ring of rocks packed tightly together, like stepping stones across space. In reality, the belt is vast and mostly empty. If you were to stand on one asteroid, the next nearest might be hundreds of thousands of kilometers away. Yet spread across this region are millions of bodies, ranging from dust-sized grains to worlds hundreds of kilometers wide. The discovery of the asteroid belt began in the early 19th century. Astronomers, following a mathematical rule called the Titius-Bode law, expected to find a planet between Mars and Jupiter. In 1801, Giuseppe Piazzi discovered Ceres, the first and largest asteroid, which turned out to be nearly 1,000 kilometers across. Soon after came Pallas, Juno, and Vesta, each new find revealing that the missing planet was not one body, but many. Over time, thousands more were cataloged, and today, with modern telescopes and sky surveys, we know that the asteroid belt contains millions. Ceres itself is so large that it is now classified as a dwarf planet. Unlike many asteroids, which are irregular chunks of rock, Ceres is spherical, shaped by its own gravity. Beneath its surface may lie layers of water ice, and evidence suggests that salty brines once seeped through its crust. It is a world with hints of complexity, perhaps even geologic activity, standing apart from the rubble around it. Vesta, another giant of the belt, tells a different story. Once partially molten, it developed layers like a miniature planet with a metallic core and rocky crust. Enormous impacts in its past have blasted chunks of Vesta into space, and some of those fragments have fallen to Earth as meteorites. To hold a piece of Vesta in one's hand is to touch material from deep within an asteroid's crust, carried across millions of kilometers. But not all asteroids are so massive or complex. Many are far smaller, irregularly shaped, and loosely held together. These are sometimes called rubble piles, clusters of boulders and dust bound by weak gravity. When struck, they may shift and settle rather than crack apart. Missions like Japan's Hayabusa and NASA's OSIRIS-REx have visited such bodies, revealing landscapes of boulders, slopes of shifting dust, and craters piled upon craters. These rubble piles are fragile but ancient, survivors of countless collisions. Asteroids are also categorized by their composition. C-type or carbonaceous asteroids are the most common, making up about 75% of the known population. They are dark, rich in carbon and other primitive materials. These bodies may contain water-bearing minerals and organic molecules, making them important in understanding the origins of life. S-type or silicate asteroids are brighter and made mostly of rocky minerals. They are thought to be fragments of larger bodies broken apart long ago. M-type or metallic asteroids are rarer, composed largely of iron and nickel. These may be remnants of cores from ancient protoplanets stripped of their outer layers by impacts. The diversity of the asteroid belt reveals the complexity of the solar system's past. These are not random stones, but survivors of an era when planets were forming, colliding, and scattering. Each carries a different history, some rich in water, some baked dry, some shattered and reassembled. Together, they form a record of processes that shaped not only themselves, but also Earth and its neighbors. Yet, for all their variety, the asteroids of the belt remain bound by Jupiter's influence. The giant planet's gravity sculpts the region, creating gaps known as Kirkwood gaps, where orbital resonances clear away bodies. Asteroids caught in these resonances are nudged into unstable paths, sometimes flung out of the belt entirely. Some of these exiles find themselves crossing Earth's orbit, becoming near-Earth asteroids. Thus, the belt is not static. It is a reservoir, continually sending fragments into the inner solar system. There are also families of asteroids, groups that share similar orbits, born from ancient collisions. When a large asteroid shatters, its pieces spread out over time, but their paths through space remain linked. By studying these families, scientists can trace events millions or even billions of years in the past. Each family is like a cosmic surname, carrying the memory of a shared origin. The asteroid belt is not the only home of such bodies. Beyond Neptune lies the Kuiper belt, and still farther, the Oort cloud, both reservoirs of icy objects, but the main belt remains the closest and most familiar, a frontier that spacecraft have crossed and studied. Probes like NASA's Dawn mission, which visited both Vesta and Ceres, have given us close-up views that transform the belt from abstraction to reality. We see craters miles wide, mountains taller than Everest, lands of dust and stone where sunlight falls in unbroken silence. What is perhaps most striking is how these worlds, so small compared to planets, can still hold such grandeur. On Vesta stands Rhea Silvia, a mountain towering 22 kilometers high, among the tallest in the solar system. On Ceres, bright spots of salt reflect sunlight, hinting at hidden briny water. Even in rubble piles like Bennu or Ryukyu, the landscapes are alien and dramatic, with cliffs, valleys, and surfaces that defy expectation. For humanity, the asteroid belt is both a place of study and of potential future use. Mining its metals could one day support industries in space. Extracting water could supply fuel and life support for explorers. And yet, beyond practical value, the belt is also a place of wonder, where the leftovers of creation still drift in quiet orbit, unchanged for billions of years. As we continue, we will leave the calm expanse of the belt and turn our attention to asteroids that wander closer to Earth. These are the ones that approach our planet, sometimes passing peacefully, sometimes striking with force. They are the reminders that while the belt is distant, its fragments can become immediate, shaping not just Earth's past, but perhaps its future. Not all asteroids remain confined to the belt between Mars and Jupiter. Some drift inward, their orbits altered by the gravity of planets, collisions with other bodies, or the subtle push of sunlight over countless ages. These are the near-Earth asteroids, cosmic wanderers whose paths cross dangerously close to our own. Unlike the distant belt, these bodies are neighbors, and their presence brings both fascination and unease. A near-Earth asteroid is defined by its orbit. If it approaches within 1.3 astronomical units of the Sun, it enters Earth's vicinity. Among these, there are further categories. Apollo asteroids cross Earth's orbit, moving in long ellipses that bring them sometimes closer than the Moon. Amor asteroids come close, but do not quite cross our path, skimming the outer edge of Earth's orbital lane. Atira asteroids are rarer still, orbiting entirely inside Earth's path around the Sun. Together, these populations number in the tens of thousands, and more are discovered each year. What makes near-Earth asteroids so captivating is the mixture of danger and opportunity they represent. On one hand, their proximity means they pose the most immediate threat of impact. On the other, it makes them the most accessible for spacecraft, offering chances to study them directly and perhaps one day to use their resources. Some encounters are breathtakingly close. Asteroids have passed between Earth and the orbit of our geostationary satellites, closer than 36,000 kilometers. In cosmic terms, this is a hair's breadth. One such visitor, asteroid 2020 QG, zipped past at only 3,000 kilometers above Earth's surface, less than the distance across the United States. It was small, no larger than a car, but the encounter served as a reminder that space is alive with motion, and not every object announces its arrival far in advance. Yet not all near-Earth asteroids are small. Some stretch for hundreds of meters, even kilometers. These are the bodies that, if they were to strike, could devastate entire regions or plunge the planet into global crisis. Fortunately, such impacts are rare. A collision with a 1-kilometer asteroid is expected only once every few 100,000 years. But the possibility remains, written into the equations of orbital mechanics, waiting in the vastness of time. To understand this threat, scientists watch these asteroids carefully. Their orbits are mapped and refined with every new observation. Most are harmless, their paths missing Earth by safe distances, but occasionally calculations reveal a small chance of collision decades or centuries in the future. Such objects are placed on risk lists, watched closely as their movements are tracked with radar and telescopes. With each new measurement, the uncertainty shrinks, and often the risk fades away. Still, the act of watching itself is vital. It is a form of vigilance that stretches across generations, a quiet defense against the slow dance of gravity. For humanity, near-Earth asteroids are not only a hazard, but also a doorway to exploration. Their proximity makes them easier to reach than the Moon in some cases. Missions like Japan's Hayabusa and Hayabusa 2, or NASA's OSIRIS-REx, have traveled to such bodies, collected samples, and returned them to Earth. The material they bring back is older than our planet's oldest rocks, fragments of the dawn of the solar system preserved in untouched silence. By studying them, we learn not only about asteroids themselves, but about the chemistry that seeded Earth with water and organic molecules, the very ingredients of life. There is also the dream of using these bodies as stepping stones into space. A near-Earth asteroid rich in water could be mined to provide oxygen and hydrogen, fuel for journeys deeper into the solar system. Metals within could support future industry. Instead of carrying all resources from Earth, explorers could use what is already drifting nearby. In this vision, asteroids are no longer threats, but allies, offering their ancient stores to help humanity expand outward. Yet, the duality remains. The same asteroid that could one day be a source of water or minerals could also, if nudged by gravity into the wrong path, become a weapon of unimaginable scale. In this sense, near-Earth asteroids embody the precarious balance of our place in the cosmos. They are both opportunity and risk, both neighbor and intruder. When we look at the Moon, we see countless scars left by such impacts. Earth, too, has been struck many times, though weather and tectonics have erased much of the record. The craters that remain in Arizona, Canada, Siberia, are reminders of what can happen when a wanderer from space meets our fragile world. The story of near-Earth asteroids is therefore not only a tale of orbits and resources, but of survival itself. And so we continue to watch. We map their paths, we dream of journeys to their surfaces, and we prepare quietly for the possibility that one day one of them may come too close. For now, they remain silent companions, drifting through the darkness, crossing Earth's path again and again, sometimes close, sometimes far, but always reminding us that our planet is part of a larger and ever-changing system. As our journey continues, we will explore the great impacts of the past in more detail, the craters they left behind, the evidence written into stone, and how these scars tell the story not only of destruction, but also of renewal. For every impact reshapes not just the land, but the destiny of life itself. All across Earth's surface, there are scars, not always visible to the casual eye, but written deep into the stone. These are the marks left by great impacts, reminders that our world has been struck again and again by asteroids of immense power. Each crater tells a story not only of violence, but of transformation. To trace these craters is to trace the hidden history of Earth's encounters with the cosmos. One of the most striking examples is the Chicxulub crater in the Yucatan Peninsula of Mexico. More than 150 kilometers wide, it was formed 66 million years ago when a 10-kilometer asteroid collided with Earth. The force of the impact vaporized rock, hurled mountains into the sky, and triggered global fires. The shockwaves circled the planet, and a veil of dust and sulfur darkened the skies for years. In that darkness, plants died, oceans cooled, and 3/4 of Earth's species vanished, including the dinosaurs. Yet from this devastation came a new chapter of life. Mammals rose to fill the empty world, and from them humanity eventually emerged. Chicxulub is therefore not only a symbol of destruction, but of renewal. Older scars are harder to find, but they exist. In South Africa lies the Vredefort crater, one of the largest impact structures on Earth. Formed over 2 billion years ago, it is nearly 300 kilometers across. Time has softened its features, worn down by erosion and reshaped by geology, but its scale speaks of an impact so massive that it reshaped the very crust of the planet. The crater is now a ring of low mountains encircling land where towns and farms quietly go about their business. Few who walk there realize they are standing on the edge of one of Earth's greatest wounds. In Canada, the Sudbury Basin tells a similar tale. About 1.8 billion years old and 250 kilometers wide, it was born when a giant asteroid struck what is now Ontario. The impact melted rock on a scale that can scarcely be imagined, creating vast deposits of nickel, copper, and platinum. Today, those metals are still mined, a reminder that even destruction can leave gifts behind. From fire and impact came resources that humanity would one day use to build its cities, machines, and technology. Not all craters are so vast. Some are smaller, but no less striking. In Arizona lies Meteor Crater, also known as Barringer Crater. Just over a kilometer wide and 170 meters deep, it was formed about 50,000 years ago by an asteroid only 50 meters across. To stand at its rim today is to see a perfect bowl carved into the desert, a scar still sharp and clear. Unlike the eroded giants of ancient times, Meteor Crater is young, its story still fresh. It is a stark reminder that even modest asteroids can unleash extraordinary power. Farther afield, the Papagaï Crater in Siberia stretches 100 kilometers across, formed by an impact 35 million years ago. The force of that strike was so intense that it transformed graphite in the ground into vast quantities of diamond. Though remote, it remains one of the largest diamond deposits on Earth, another strange legacy of cosmic violence. Each crater is a chapter, but together they form a larger story. They remind us that impacts have shaped the planet's evolution. They have altered climates, created resources, ended species, and opened paths for new ones. Without them, Earth's history would be unimaginably different. What is striking is how often these scars are hidden. Erosion, vegetation, and the restless movements of Earth's crust conceal them. Many were only discovered in the last century, revealed by satellites, geophysical surveys, or mining operations. The land we walk upon carries memories older than mountains, but they lie buried, waiting to be uncovered. And yet, for all that has struck Earth, many more impacts have been erased entirely. Unlike the moon, where every crater remains visible in stark relief, Earth has water, wind, and tectonics to heal its wounds. Oceans swallow impacts, volcanoes bury them, glaciers scrape them away. Our planet remembers, but imperfectly. The moon shows us what Earth has forgotten, a face pocked with scars, each one a frozen reminder of how common impacts once were. To study craters is therefore to glimpse not just Earth's history, but the history of the solar system. They reveal the restless motion of asteroids, the chaos of early planetary formation, and the fragile balance of life in a cosmos filled with wandering stones. Each crater is a monument to chance, to the alignment of orbits, the pull of gravity, the inevitability of collision. Yet in those scars, there is also perspective. They remind us that humanity's story is written against a backdrop of immense forces. Our civilizations, our histories, all unfold on a world that has been reshaped by blows from beyond. The fact that we are here at all is the result of survival through countless impacts and of one fateful strike that cleared the way for mammals and, eventually, humans. As we continue this journey, we will turn from the scars of the past to the possibilities of the future. What would happen if another large asteroid were to strike today? How would it affect our world, our societies, our survival? And how can we prepare knowing that the universe does not ask permission before it sends its stones to Earth? To imagine the future of Earth is to imagine not only the growth of civilizations and the march of technology, but also the inevitability of encounters with the cosmos. Asteroids have struck before, and they will strike again. The question is not if, but when, and how large the next impact will be. In contemplating this, we glimpse both danger and resilience, for Earth has endured such blows countless times, and yet life continues. Consider first a small asteroid only a few dozen meters across. Such an object would likely explode in the atmosphere, as happened over Tunguska in 1908. The blast flattened more than 2,000 square kilometers of Siberian forest, releasing energy equivalent to a powerful nuclear bomb. If such an impact occurred today over a city, the devastation would be unimaginable. Yet over oceans or remote regions, it might pass almost unnoticed by the wider world. These smaller impacts are frequent on cosmic timescales, perhaps once every few centuries. They remind us that even modest wanderers can wield immense power. Now imagine an asteroid a few hundred meters wide. This scale of object could level an entire region, generating shockwaves, firestorms, and tsunamis if it struck the ocean. The Chelyabinsk meteor of 2013, though only 20 meters across, injured over 1,000 people through shattered glass alone. Multiply its size tenfold, and the consequences rise beyond imagination. Such impacts occur less often, perhaps once every tens of thousands of years, but they remain possible in the span of human history. And then there are the giants, asteroids a kilometer or more across, A strike of this magnitude would not merely devastate a region, it would disrupt the global climate. Dust and soot would rise into the atmosphere, blocking sunlight, cooling the earth. Crops would fail, ecosystems would collapse, and humanity would face the challenge of survival in a world suddenly altered. Impacts of this scale are rare, occurring only once every few 100,000 years. But they have happened, and they will happen again. Finally, consider the unimaginable, a body 10 kilometers across, like the one that ended the reign of the dinosaurs. Its impact would mark the end of an age. Such events are measured not in human years, but in the epochs of geological time. They occur perhaps once every 100 million years, yet the scars of Chicxulub remind us that even the rarest events can shape the destiny of life itself. The effects of a future impact would depend not only on size, but on location. A strike in the ocean could send tsunamis racing across entire basins, washing away coasts and cities. A strike on land could ignite forests, shatter mountains, and send shockwaves across continents. In either case, the atmosphere would carry the burden, dust and vaporized rock rising to block the sun. For weeks or months, the skies would darken, temperatures would plummet, and ecosystems would struggle to survive. Yet humanity has something that the dinosaurs did not: awareness. We watch the skies, track the orbits, calculate the risks. We have begun to develop tools to alter the path of dangerous bodies, to prepare for the possibility of defense. Missions like DART show that even a small spacecraft striking at great speed can shift an asteroid's orbit. With time and planning, such interventions could save the Earth from disaster. The key is foresight, finding the threat early when the smallest nudge can make the greatest difference. There is also resilience. Human societies have faced disasters before: eruptions, earthquakes, plagues, wars. An asteroid strike would be catastrophic, but it would not erase the spirit that adapts, rebuilds, and remembers. Just as life found a way after Chicxulub, so too would humanity strive to endure, using knowledge, cooperation, and perhaps even the very resources of asteroids themselves to begin again. Asteroids thus embody a paradox. They are harbingers of destruction, yet also carriers of possibility. They have brought death, but also the water and organics that gave rise to life. In the future, they could threaten Earth, or they could sustain humanity's expansion into the solar system. They are both enemy and ally, both peril and promise. To imagine the end of Earth through asteroids is to imagine one possible thread of destiny. It may come tomorrow or in 1,000,000 years, but it also reminds us that the universe is not static. It moves, it changes, it collides, and within that movement, life itself finds its path, fragile, resilient, and ever adapting. As our journey continues, we will turn to another question. What role might humanity play in this cosmic balance? Could we become not only watchers, but active shapers of our fate, turning asteroids from threats into tools, guiding their paths instead of fearing them? The next part of our story will explore this vision, where science and imagination meet, and where the rocks of space may become the stepping stones of our future. When we look at asteroids, it is easy to see only the threat, the possibility of destruction from a sudden impact. Yet hidden within these bodies is also the possibility of survival, even prosperity. Humanity is beginning to imagine a future where asteroids are not just obstacles in space, but resources, allies, and stepping stones into the wider solar system. Asteroids are made of many things: stone, metal, carbon, and even water ice. Each of these has value. The metallic asteroids, rich in iron, nickel, and platinum group elements, hold more raw material than has ever been mined on Earth. A single metallic asteroid a kilometer wide could contain more wealth in metals than all the mines of our planet combined. For a civilization looking to expand beyond Earth, these resources could fuel an age of construction, habitats, spacecraft, industry, all built from materials gathered in space rather than lifted at great cost from Earth's gravity. Water-bearing asteroids may be even more important. Water is not just for drinking. It can be split into hydrogen and oxygen, the ingredients of rocket fuel. A future outpost on or near such an asteroid could refuel ships, making long voyages deeper into the solar system practical. Instead of carrying everything from Earth, explorers could use what space itself provides. This is the vision of in situ resource utilization, a way to live among the stars by using the resources already waiting there. The idea of mining asteroids once belonged only to science fiction, but now serious plans are being developed. Private companies and national space agencies alike have begun to study how it might be done. Robots could land on small bodies, drill or scoop their surfaces, and process materials either on site or in orbit. Some suggest towing small asteroids closer to Earth or the Moon, placing them in stable orbits where they could be harvested more easily. These are ambitious ideas, but not beyond imagination. Beyond mining, asteroids could serve as way stations. Their low gravity makes them easy to land on and leave again, offering safe harbors for spacecraft. Some may one day host research stations or even permanent bases. In such a vision, the asteroid belt itself becomes a new frontier, a region dotted with human settlements, each tied to a different rock, each part of a growing web of civilization stretching beyond Earth. Asteroids also carry a subtler gift: knowledge. By studying them up close, we learn about the earliest days of the solar system. They are time capsules, preserving chemistry and structure from over 4.5 billion years ago. Missions like Hayabusa, OSIRIS-REx, and future explorers bring back samples that tell us not only what asteroids are made of, but how planets formed, how water came to Earth, and perhaps how life's building blocks first arrived. To hold a fragment of an asteroid is to hold a piece of cosmic history, older than Earth itself. There's another, more poetic possibility. If asteroids have carried destruction and life in equal measure, perhaps humanity's future lies in mastering both. By turning asteroids into resources, we transform them from threats into partners. By learning to deflect them, we take the first step in planetary defense, protecting not just ourselves, but future generations from catastrophe. In this way, asteroids become symbols of humanity's growth, once feared as omens, then studied as mysteries, and finally embraced as tools of survival. The path forward will not be simple. Mining asteroids will require technologies we have only begun to test. Living among them will demand resilience, creativity, and adaptation. There will be dangers, unstable surfaces, radiation, isolation. Yet every frontier in history has begun with risks, and each has opened doors to possibilities that once seemed impossible. Perhaps one day, centuries from now, Earth will no longer be humanity's only home. Cities might float within hollowed asteroids, protected by thick walls of rock. Farms might grow under domes on spinning stations built from asteroid metals. Trade routes might pass through the belt, carrying not only goods but stories, cultures, and lives. In such a vision, the same bodies that once threatened Earth's existence become the foundation of a civilization stretching across the solar system. Asteroids may also hold the key to survival beyond Earth. Our planet is fragile, vulnerable not only to impacts but to our own actions. To spread beyond Earth is to build resilience, to ensure that humanity can endure even if disaster strikes our home. Asteroids, wandering between worlds, offer the first steps on that path. They are like scattered islands in a cosmic ocean, waiting for sailors to land, rest, and move on. And so, the future of humanity and asteroids is not written only in fear, but in possibility. These stones from the void are both reminders of our vulnerability and invitations to dream. They whisper of destruction, but also of construction, of endings and beginnings. As our journey nears its end, we turn to the largest question of all. What is the ultimate fate of Earth, and how might asteroids play their part in it? Will one final impact one day close the story of our planet as it has closed the chapters of so many species before us? Or will humanity, armed with knowledge and vision, find ways to endure, to adapt, and to carry Earth's legacy into the wider universe? In the vastness of cosmic time, Earth is but one world among billions, fragile yet resilient, temporary yet enduring in its own way. Asteroids, those wandering fragments of stone and metal, have been companions from the beginning. They were present at the birth of the solar system. They shaped the story of our planet through fire and impact, and they remain orbiting silently, reminders that the universe is always in motion. The question of Earth's ultimate fate is inseparable from theirs. One day, perhaps far into the future, a massive asteroid will again collide with our planet. It may be in 1,000,000 years or in 100 million. Its timing cannot be known, but the scars on Earth's crust, the craters on the moon, the stories in stone, all say the same thing. Impacts are inevitable. Just as they ended the age of the dinosaurs, they may one day end ours. Yet destiny is not only written in falling stones. Humanity is no longer powerless before the sky. We have eyes that watch, instruments that calculate, and machines that reach into the void. We can see danger coming, and we can imagine ways to turn it aside. In this sense, asteroids are no longer only threats. They are challenges that test our ingenuity, our cooperation, and our will to survive. If we learn to deflect them, we prove that intelligence can alter fate, that life can shape its own story rather than accept it blindly. Asteroids also hold the possibility of partnership. They are vaults of resources, time capsules of history, stepping stones to other worlds. In their stone and metal lie the keys to expansion, to resilience, perhaps even to immortality as a species. If humanity spreads to the asteroids, to the moon, to Mars, and beyond, then no single impact could erase us. Earth may still bear scars, but the story of life will continue elsewhere, carried on ships built of asteroid metal, fueled by asteroid water, guided by knowledge written in asteroid dust. And so the tale of asteroids and Earth is one of duality. They are both destroyers and creators, enemies and allies, omens of endings and promises of beginnings. They have killed, but they have also seeded oceans and skies. They remind us of fragility, but also of possibility. In them, we see the mirror of existence itself, the balance of chaos and order, of loss and renewal, of endings that open into new dawns. Perhaps one day, Earth will indeed fall to a final strike, its surface scarred beyond recognition, its its oceans boiled, its skies darkened. But perhaps by then, humanity will already have journeyed outward, carrying memories of its first home, telling the story of the blue planet that once thrived under the sun. In that story, asteroids will appear not only as harbingers of doom, but as teachers, the first tests we overcame, the first worlds we touched, the first bridges we crossed into the greater cosmos. For now, Earth continues, alive with forests and oceans, cities and dreams. The asteroids still wander, silent as they have always been, circling in endless paths around the sun. Most will never touch us. A few may come close. One may one day arrive with fire, but whether as threat or ally, they remain bound to our story, inseparable from the fate of our planet. The end of Earth, if it comes by asteroid, will not be an isolated event, but part of a greater cycle, the same cycle that gave us water, life, and time. In this, there is a strange comfort. The stones that may one day end our world are the same stones that helped begin it. Endings and beginnings are not opposites, but partners in the same cosmic dance. So when we look up at the night sky and see a meteor streak across the darkness, we are witnessing more than a fleeting spark. We are seeing a fragment of that endless cycle, a reminder of our past, a whisper of our future. In its brief light is the story of Earth itself, fragile, powerful, temporary, eternal. And as long as we watch the sky, as long as we wonder, we remain part of that story. For the universe is not indifferent. It is alive with motion, with change, with chance. Asteroids remind us that we live within it, shaped by it, and perhaps destined one day to shape it in return.